Actually, it's just the percentage composition. Okay, we know that sodium Na it's 32.38%, that sulfur S is 22.65%, and oxygen O it's 44.99%. Well, I got 100.02%. So the problem is giving us the percentage composition. So to calculate the empirical formula, what we do in the first step is, if we start with the percentage composition, we are going to, in the first step, we're going to convert from percentage to grams. How do we do that? So easy that you won't believe it. What we're gonna do is we're gonna change the percentage symbol for grams. Okay, now instead of having a sample, an unknown sample, we're gonna have 100 grams sample. So Na is gonna be 32.38 grams, sulfur 22.65 grams, and oxygen 44.99 grams. That is the first step. In the second step, I will get the number of moles. In the second step, I will get the number of moles of each element. So, for sodium, this will be 32.38 grams times, basically we're gonna do we're gonna use molar mass as a conversion factor. Okay, and for sodium we have, so for sodium is, in 1 mole of sodium I have 22.989 grams. Cancel. For sulfur I have 22.65 grams times my molar mass as a conversion factor, that is 32.064 grams in 1 mole of sulfur. And for oxygen I have 44.99 grams times, in 1 mole of oxygen, 15.999 grams. So perform this in your calculator. This is what I got. Okay, these are the masses. That's what I got. Now, the next step is, in the third step, it's so easy. You will see. In the third step, what we do is, sorry about the spot over there. What we do is we're going to choose, or we're going to highlight the list of the results. As you can see, this is my list amount of moles. So everything, this and that, I'm going to divide by the least amount. That is 0.71, and divided by 0.71. Perform this in your calculator. 1.41 divided by 0.71 gives me 1.99. Okay, 0.71 divided by 0.71 is going to give me 1. And 2.81 divided by 0.71 gives me 2.96. Now, these numbers 1.99 and 2.96 are really close to whole numbers. So right now what you do is you round, multiply by a multiplication factor. If you have one of these decimals, you have to multiply or round. In this case, what we need to do is, because the numbers are really close to a whole number, we're going to be rounding. Okay, so 1.99 it's approximately equal to 2. Okay, 1 is going to be 1 because it's a whole number, and this is approximately equal to 3. And in my last step is the empirical formula. Okay, empirical formula. So what we're gonna be writing is the elements, okay, and the ratios. How much sodium? 2. How much sulfur? 1. How much oxygen? 3. And this is our empirical formula. Okay, now we have another example. Now I'm not giving you percentage composition. I have analysis of a 10.15 gram sample of a compound known to contain only phosphorus and oxygen. Indicates a phosphorus content of 4.433 grams. What is the empirical formula of this compound? Okay, now that we don't have the percentage composition, but we do know the mass. My total sample is not 100 grams now. It's just 10.15 gram sample. And this compound contains only phosphorus and oxygen. I know only the phosphorus content, that is 4.433 grams. But I know that the whole pie for that same is 10.15 grams. So I know the rest is going to be just oxygen. The rest of the grams. But how much is that? Well, a simple process, 10.15 gram minus 4.433, it's going to give me the amount of oxygen. And this is 5.717 grams of oxygen. Now, that is my first step for that saying. In my second step, or the next step, is I'm going to get the percentage composition. Okay, the percentage composition. So what I'm going to do is I'm going to take phosphorus and oxygen. Okay, I'm going to take its individual masses and I will divide by the total mass, then multiplying by 100. So it's going to be phosphorus mass divided by the total times 100, and this is going to be oxygen divided by the total multiplied times 100. This is a normal percentage formula. Okay, so this is going to be 4.433 divided by 10.15 times 100. .67%, and this is going to be 5.717 divided by 1015 times 100. this should be the remaining of the 100. Okay, so this will be 53.33 rounded percent. If you add this and the other, it's going to give you 100%. Now, we got here from grams to percentage composition. Now it's our turn to get what? The grams in a sample of 100 grams. Okay, now from percentage to grams. So I'm gonna have, for phosphorus, I'm gonna have 43.67 grams, and for oxygen I'm gonna have 53.33 grams. In the next step, I'm gonna have my number of moles. I'm going to divide this. Okay, my number of moles for phosphorus and for oxygen. I will be using the molar mass as a conversion factor. So for my phosphorus, I'm gonna have 43.67 grams times the molar mass as a conversion factor, that is 30.973 grams in 1 mole. So this will give me the amount of moles. For oxygen, it's gonna give me 53.33%, that as grams. And in 1 mole of oxygen, I have 15.999 grams. Cancel grams and grams. Okay, now get the number of moles. Okay, knowing the amount of moles of phosphorus and oxygen respectively, what we have to do is we need to divide by the least amount of moles. In this case, between 1.41 and 3.33, the least amount is 1.41. So in my other step, my first step is going to be dividing phosphorus. It's gonna be 1.41 divided by 1.41, and for oxygen it's gonna be 3.33 divided by 1.41. Okay, so this is going to give me 1 as a whole ratio, and oxygen is gonna be 2.36. Okay guys, I just realized I have a mistake here. It was 56.33. So let's see. I did all the changes now. Okay, it converted to grams, I already did the correction. Converted to mole, I already did the correction. And here, so 3.52 divided by 1.41 gives me 2.5. 2.5 2.5 moles. Okay, now take a look. And the next step that I showed you in the exercise before, it says that right now you write off the empirical formula. But the empirical formula should always have whole numbers. And as you can see, now I have a number, a decimal number, 2.5. So the next step is, before writing the empirical formula, you have to search for the equivalent of the fraction. That means 2.5. The decimal part is 0.5. Okay, so that means that here you're going to be looking for that decimal part. As you can see, 0.5 is here, okay, and it's a fraction of 1/2. Multiply the decimal equivalent by the number in the denominator. The number in the denominator in 1/2 is 2, in order to get a whole number. So that means that this, I have to multiply all of it times the denominator 2, okay? Or in other words, if you have a decimal number of 0.5, multiply times 2. If you have, for example, of 0.66, multiply times 3. But you have to multiply times this number, but all the elements, not just the one decimal. Okay, so what we do right now is we're gonna be multiplying times 2, okay, because of this, times 2, because we have the decimal 0.5, which is 2.5. Okay, now what's gonna happen, that now our empirical formula, it's gonna be now, this is the empirical formula, okay? It's gonna be made of phosphorus 1 times 2, 2 phosphorus, oxygen 2.5 times 2, 5. This is the empirical formula for this compound. As a review, first, in the case that you don't have the percentage composition and you have, for example, the grams, convert to get the percentage composition of it. From this, convert to grams. From this, divide by the molar mass to get the number of moles. Then you will divide by the least amount, that is 1.41 in this case. And the number that you get, if you get a decimal number, you need to multiply times a multiplication factor that I have over here. As you can see, 2.5 should be multiplied times 2, because it ends in 0.5. Just the 5, not 75 or 25. The 5 alone is multiplied times 2. And here is how you get the empirical formula. Phosphorus 1 times 2, 2, and oxygen 2.5 times 2, 5.